Yes, that is a train running on MRR2. We're going to go over how we got to that point in this video. Welcome back, everybody. Before we get going, I want to show you the finished product right here. This is my DCC bus, pretty much completely wired. It's got a few more things I need to add to it. But what I've done basically is I've wired an entire system in a parallel. So what I have right here is I have my main bus. This connects directly to my DCC system, which in this case is DCC++EX, and then connects to all the different sub buses where the bus line goes. And you have like this one right here, which is the main track bus, which does the majority of the feeders, and then you have some smaller connections for a couple things that I'm going to get to later on in this build. And then from the sub buses you have wires connecting the feeder wires going to the tracks.
Here's a quick little diagram of how I do my DCC bus setup in parallel. You can see how I have the distribution bus that comes directly from the DCC system, and then it splits off onto the different sub buses which connect to track and accessories.
The big thing about using a parallel system like this is A, it makes it a lot easier to find issues if you have them, and B, it's going to cause less issues in general. So you don't have to worry about a whole system in series where if one messes up, they all mess up. So I'll be able to isolate which one is messing up, and it makes it a lot quicker to troubleshoot. So let's get into installing this DCC system.
When we last left off, this is where we were. I had installed the turnout motors and it was time to do some DCC wiring. To do this, I was going to be using some of these inexpensive terminal strips, and what I need to do was link one side of them together completely. That way they would work as one giant connector for one wire of the two bus wires that I would need for the DCC system. Now, the pack of these that I bought came with these connectors right here, and I will link that in the description below. Next up, we need to attach these. All I'm doing is using a screw that fits properly, and then just making sure it's not too long as it won't poke through the back. I then installed the second terminal strip that I'm going to be using for the red wires. For my DCC bus, I'm going to be using red and black for the colors, and it's important that you use two different colors. The reason for this is if you get your wires crossed, you will have a short and your DCC system won't run. Next up, I need to create some pass-throughs in the center support joist of my layout. So I grab a 1-inch spade bit and go ahead and start drilling through so that I can have two pass-throughs through my layout for wiring. Once that is done, I put in all of my different DCC terminal strips in, and then I can start wiring the track. Now, there are a lot of different rules of thumb for how many feeders you should connect to track. I've heard 1 every 3 pieces, especially if you're using flex track. I am going to be putting a connection on every different section of track. To make the holes for the feeders, I'm using a 1/8 inch drill bit, and I'm slowly making a hole in between two of the ties. Now, one thing that's very important is you want to go through and you want to make the hole as clear as possible, so you'll see me go down and up a couple times just to make sure that everything's clear so the wire can be fed up through. In order to add a little bit of realism, I space out where my connectors for each rail go. I put one right here, and then I'll put the other rail a little further down. I don't like to have them at the same location because it can do a little bit of illusion breaking when you are putting everything together. And then it's just a matter of rinse and repeat, drilling those holes, making sure that every section has feeders so that it is operational. We don't want any breaks in current, especially on a layout this small. We want the DCC system to be rock solid so that we don't have anything going on. Another thing that I do is I take a Sharpie and mark where each one of the holes for the feeder wire is. Obviously, we're going to cover this up with paint and scenery later, so it doesn't really matter how much we mark, but this just makes it a little bit easier to find them when you are working through this, because it can actually be a little difficult to see exactly where you're working. So I'm just taking this and marking each hole. Now, what I'm doing right here is a headache saver right here. I am marking what color each one of the holes is so that when I'm threading the feeders up through them, I will not have any issues with getting the wires crossed and causing short circuits. So I'm just looking and double checking my connections and just marking which one is which, and this makes life a lot easier, especially when you're trying to find short circuits. Now it's time to warm up the soldering iron and get to work. I'm going to be soldering my feeders, obviously, because I'm bringing out the soldering iron. The first thing that I do is I apply a little bit of flux to the area where I'm going to be soldering. Flux helps burn off any impurities when you are soldering. So putting a little bit of this on there will make your connection more solid. Next up, I have a flat tip on my soldering iron, and I'm going to preload some solder on it. This is going to make it easier to solder. I'm going to put a little pad on there so that the connection can be made easily. So I'll just bring my soldering iron and touch where I put the flux on there, and then it will seep in there and make it easier to make the connection. Notice how I'm slowly pulling it across. This is where the flat iron helps out a lot. This will help the solder be a little bit flatter and you don't have bubbles of solder on your track that look unrealistic. Next, we feed our feeder through here, and it is 22 gauge solid wire, and I'm going to give it a nice little bend so that A, it doesn't fall back in the hole, and B, we can go ahead and put it into position for soldering. The first thing I'm going to do is tin the tip of the wire. Notice I've already stripped it so that it was a lot easier to do, and I didn't have to do that when I pulled it through. Then you feed the wire back through to where it's minimally showing and bend it into position. This is where the solid wire really comes in handy. Not only is it going to be easier to hide, but it's going to be easier to maneuver into a position where it's going to look realistic, and it's going to be really hard to see those feeders. And I'm taking just some screwdriver, just whatever tool works best right here, and I'm really pushing it into the rail right here just to get it as close as possible, just so I can have that wire as hidden as possible. I'm not worried about anything with the ties or anything like that. They're all insulators, so I'm not worried about the bare wire. Obviously they're touching the rails, so nothing's going to go there, but I do that, and then I'm going to bring my soldering iron back in and connect the two with the solder that's already on both the pad and the rail and where I tinned the tip of the wire. Now, one little neat trick I found is these little wire strippers, which are pretty standard wire strippers, are actually fit perfectly in between the ties to push the wire even more in place so you can hide the wire even better. And now it's just a lot of rinse and repeat, just going through and soldering all of the connections and just making sure that I get them as flat and neat as possible. So this is where you really want to take your time, because if your layout doesn't work right, then you could have some issues. Then you can connect your feeders to all of the proper terminals that you have here and then get everything connected up. This is another place where having the wires with standard colors that you've decided on will save you a bunch of headache. Next up, let's solder some of the rail joiners together so that we have as solid of connections as possible. So the first thing you want to do, just like when you're soldering the feeders on there, is put some flux on there just to burn off those impurities. Then once you're done, you can preload some of your solder onto your tip and then just kind of gently pull it across the joint, and it should flow fairly well right there into the web of the rail.
All right, so we have everything wired, but it's kind of a mess. So I'm going to take my staple gun right here and just kind of get all the wires neatened up. Now, if you're not comfortable using a staple gun, you can always use wire clips or something like that. You just need to be careful not to pierce the wires with the staples, which this kind of staple gun has a good guide for it. So we're going to go ahead and get started on that. All right, we've got everything hooked up. The DCC++ EX system is hooked up underneath and powered on. So all we have to do is power on the locomotive, and we have this cheap little Bachmann with some sound on it. So we're going to go ahead and turn on the sound. So far, so good. Get some bells. Now for this kind of layout, slow speed is critical, so let's go ahead and give it a test. So far, so good. Uh-oh. Now, that is an issue. That is a little stutter that happens as the train is going over the frogs on the turnout. And in our next video, I'm going to go over how to fix that. Thank you guys so much for watching. Until next time, I'm Jimmy from the DIY and Digital. Stay safe, be kind, and happy railroading.